really boring. Terrible. No. Nation points. Amazing. Amazing. Ah, that's a good way. That's a good way to spin it. Yeah. Absolutely. Hmm? That's what we'll say. Right. Yes. Okay. Okay, let's see. What's going on? Who is here? The poll. Let's see. Quick poll here. See how many people show up early. Poll. A little bit of a poll. Let's see. How many students show up on time, basically? All right, Gath. Yeah. All right. See you later. Alrighty. 11:30. 11:30. That's when class begins. All right. The fundamental idea. First example. Writing my notes here. No fixed time. There is no fixed time. But I don't recommend closing the tab. Okay. Oh, wait. Okay, fine. Let's do this. Headline. Let's change the headline here. Give me 5 hours. Okay, here we go. First exam will activate at 1. Okay, class. You see this? First exam will activate at 1. Good. All right, let's go. Get ready. 45-minute lectures. I'm going to remind you that that's what I'm up against here. I am up against quite a challenge. Rough weekend, yeah, very rough weekend, yeah. Got the scruff today. Okay, here we go. Um, okay. Our topic for this week, mostly the main topic is trig substitution. Ew, bad. Okay, but what I'm going to show you is that it's not that bad. So trig substitution is just another tool in our toolkit. We've got substitution, ordinary substitution that we learned in the beginning. Then we've got integration by parts. Try to like tease out product situations. It helps with products. Then we've got we're not so scared when we see trig functions multiplied with each other. That was all of last week. That's also not that scary. And now trig substitution, next technique. So I'm going to teach you the very first thing. We have to respondus lockdown browser. We have to have respondus. No, I don't know what that is. So I'm old school. So just go to Canvas. Don't look anywhere else. Do the exam. Easy. No, none of that. Whatever that is. Okay, so fundamental idea. Ready? I need to tell you the fundamental idea in underlying every trig substitution usage. Okay? So that is, ideas are fun to talk about. And so we're going to talk about that first. So you understand the name of the game. Okay. So what you do is this. You focus on the Pythagoras identity. So sine squared x plus cosine. Oh, where's my boring music? Where's that? Huh? Where's that? Okay. Plus cosine squared. Oh, thank you for following. Daylight, tem, yeah, okay. Equals 1. All right. This one. You can divide out by either. We decided to just divide out by cosine. So, oh, dingy, washcloth, yeah, thanks. Divide out by cosine squared is what we decided. You can also do the other one, and you'd get relationships between cotangent and cosecant. We just decided to focus on the tangent and secant half of the story, so we'll just keep trying to do that. You can also get by dividing out this one. So you have these two. Let's just focus on these two. All right. Okay, Dr. Young's lab. Someone shout that guy out. That person is a chemist, and yeah, good. Hello. Okay, so here are the two identities and how to think about them. How to think about these. Write this down. That's what trig substitution comes down to. Let me give a new spin, a new take on these identities. Let's write it in orange. Orange will represent the trig substitution worldview. Okay? Just like purple was integration by parts. What does it mean? If you put one of these onto one side, for example, it doesn't matter which one. Sounds like it's completely stupid thing to do. Okay. So it sounds like a completely stupid thing to do, this move. However, here's how you think about it. This is a number minus a square? Isn't it? It is. It's a number minus a squared thing. And what the whole move in trig substitution is to take something like that and trade it for a perfect square. So that's the running theme in all trig substitution. Every time someone invokes the trig substitution to crack an integral, to unlock an integral, they are gonna at some point make this kind of a trade-off. Usually a number minus a squared thing, it's like ugly, it's causing problems. They will then use this to, they'll swap it out with the squared thing, this cosine squared, okay? And similarly, here, if you look at the left-hand side, and sorry, you know what I should do everywhere? I should, since we're going to use x for a different, I don't want to confuse you. Let's put theta everywhere. So that it aligns with what I'm gonna, with the notation I'm gonna have during some examples. Okay? All right. Okay. So look, the fundamental point of view in trig substitution, the lens by which you're viewing it, is that this side is a number plus a square. And the other side trades, so you could trade this off for a perfect square. Just a squared thing. And this will work wonders. So we got to check out why that's the case. All right. So we must do our, so that's the idea. The fundamental idea is to use these trig identities to trade off something that's not a square, like a number plus a square, with a perfect square. Okay, great. So I hope you wrote that down, and now let's do examples. PogChamps, you're brimming with excitement. All 25 out of 33 students. You must be brimming with excitement. Okay, good. All right. Okay. Very first example, everyone must do. Must do first example. In fact, this example, you might as well memorize the total end result of this example. Okay, here we go. So it's the integral. And most of your homework is just indefinite integrals that involve trig substitutions to unlock them. So we're just going to stick with indefinite because let's just learn that first. Okay, fine. Here it is. 1 over 1 plus x squared. Now here's the thing. You can go all day and try to use all the tricks that we've learned so far. Oh, is there a substitution that works here? No. Nothing obvious pops out. Is there a integration by parts trick here? No. Nothing works right now. This is currently not a blue problem. This is red. But with the power of trig substitution, this becomes blue. Okay, so here's how you do it. Here's how you execute a trig substitution. Pay attention. Pay attention. You take x. And you swap it out with tangent theta, so that this whole thing, which by the way, this whole thing is a number plus a square. A number plus a square. Okay, so you trade this off, so to speak, for this thing. That's what you try to make happen. So let's try to make that happen. Here's the substitution. X is tangent of theta. In other words, into X, you insert tangent of theta. It's a different flavor of substitution that you're used to. You're usually used to cordoning off a big complicated thing with X's and calling that U. But this time we're doing in a little opposite style. Like X, you inflate it into something crazier, like tangent theta. So that's the substitution. That is the trig sub. And next, what you do is you differentiate the substitution, just like you did with U substitution. Differentiate the substitution. And you'll get dx on the left side, 1 times dx, equals the derivative of tangent theta with respect to theta. All right, here we go. That's secant squared or something. Okay, there you go. So every time you do a substitution in the context of integration, you'll have the substitution itself, and then you have to differentiate it to understand how this element changes, this symbol. Right now it's all symbolic manipulation we're doing. After we're done becoming experts at this symbolic manipulation, I'll go remind you what the heck we were computing this whole time, but only after that. Okay, thank you, Santos, for and Gangsta and all these people. Okay, here we go. Now I execute. Now execute. Execute this substitution. So you're gonna trade everything away for thetas. This says itself. 1 is 1. Now, 1 plus tangent squared theta. That's what you'd get in the denominator, right? But that trades off perfectly with secant squared theta. Incredible. So that is secant squared theta. And so this bottom becomes secant squared theta. And this was orange mathematics, right? It's at this orange stage that we traded off one thing for another thing in these Pythagorean identities. Beautiful. Okay, and then dx is replaced with this differential, secant squared. Oh my god, amazing cancellation. Insane. Insane cancellation. Now that is satisfying, I must say. Absolutely amazing. Dingy washcloth, I agree. This is just brilliant. And now, this is, remember, which variable is this problem in? What variable is operating? Theta. So the antiderivative of 1 with respect to the variable theta is theta. Okay? All right. And then you have plus c garbage. But here's the deal, folks. The problem was initially given in terms of the variable x. So, as a matter of respect, thank you, Kappa. Thank you. As a matter of respect, since the problem was given to us in terms of the variable x, you should give them the answer in terms of the variable x. And so how do you do this? Now, to be respectful. Well, you gotta translate theta back into x's, and there's only one way to do it. I mean, there's one place to look for the translation dictionary. That right there is the dictionary between thetas and x's. So you gotta go and isolate that. So x was tangent theta, and so theta is the inverse function of tangent applied to x. And there's a name for the inverse function of tangent called arctan. Other people, just other names, people also write tangent inverse. Okay? That's another way of saying arctan. These are the same thing. Tangent inverse is not cotangent. Okay. All right. It's the inverse function of tangent. Maybe after class, we'll go into my third eye and I'll go show you the graph of arctangent so you know that it's a beautiful little function. Okay? So arctan x. And it's blue now. It's so bright blue. So, in other words, summary. This integral is blue. This is an integral that we can do, and its result is fascinatingly arctangent. It's amazing. This is kind of typical situation with integration. You might integrate a function that only referred to some of the most simple operations, like x squared plus 1 division. That's what's on the left. But when you integrate it, you sort of get bumped up to a level of function that I'm sure most of my students shiver at arc10. I don't know why you do, but you shiver. So but look, here we go. This is the fact of life. It's not just an opinion. And the way to get there is through the trig substitution x equals tangent theta. All right, let me do another one. Let's play some more games. Second example. Ready? Second example. I hope I can execute it properly. Wow, disgusting. It's disgusting. By the way, notice the delicate nature of integration problems. Just a by the way. I'll write by the way math in this green color. By the way, if this 1 here was slightly changed to an x, this problem crumbles from a simple substitution. U equals 1 minus x squared. We'll crumble this problem. We'll just completely demolish it. So it's not that. So I don't want to train you to thinking whenever you see a number minus a square, you should always be thinking trig sub. No, look at it first and see if an ordinary old school tool could crumble it. So by the way, if it were an x, this is an old problem, not a new problem, a doable problem from before. But it's not, it's a 1. And that's the fundamental reason why old techniques don't really help in tackling this here insane integral. Okay? Good. Okay, so here we go. I'm going to use the orange trig substitution underlying principle to try to trade this 1 minus x squared away. Try trading it for a perfect square. Why? Because I'm square rooting. I like perfect squares underneath square roots. And so do you. Okay, so let's go do that. Okay, so now we go look at our fundamental idea. And look at this. Which of these two is more useful for us? Okay, I claim that the top one is better for us because it's trading off 1 minus a square with a perfect square. And now you go back to our example. 1 minus a square. Okay, so that suggests, this suggests the trig substitution. Inflate x into a whole trig function. Which one? Sine. Because I'm simply using this orange thing. I'm guided by this light. This light guides me. And I'm thinking of it as trading off a non-square with a perfect square. Okay, let's do it. Let's see where it goes. Where does it go? Differentiate the substitution. Always do this when you substitute. Okay, the derivative of x is dx. That's 1 times dx. And then sine theta becomes, oh yes, cosine theta. D theta. Okay, so you write both of these as the substitution of the x and the substitution of the dx element, the dx symbol. Okay, and now transform it. Go. Let's go. Put everything in terms of thetas. Go thetas. Okay, let's do that. Let's do that. Fantastic. This is incredible. Okay, first the integral symbol. Then this number 1 here. Then there's a division bar. Division bar does not get translated into any, it just stays the division bar. Square root. Very ugly. Very ugly. This is a disaster. However, 1 minus x squared. 1 minus sine squared. That's cosine squared. So don't put 1 minus sine squared in there. That's still ugly. Put cosine squared. You've got a square in a square root. Great. But then there's this d theta, dx part too, right? So dx is cosine theta d theta. All right, and then you just do, oh my God, amazing, amazing, wow. Wow, brilliant. Wow. Amazing cancellation. Okay, massive cancellation, huge conspiracy. All right, and you get theta plus c. Okay, but remember the principle of respect. Be respectful. Translate it back into the variable that they gave you the situation in. Okay, so that's great. So now, is it going to be arctan? No, because it's a different problem, folks. Look, this was the substitution cipher. Okay, and so x was sine theta, and so theta is the inverse sine function. I don't want to talk about it right now. I know you all have great opinions about it. I just want to get to something symbolic that says we finished the problem right now. Don't want to focus on that long discussion about inverse trig functions and their natural domains. So arcsine, that's what it is. So you get arcsine plus c. Boom. In other words, summary. The integral of 1 over the square root of 1 minus x squared was the arcsine plus c. Insane. Okay, let's keep going. Keep going. Okay, keep going. Go. More. Let's go. No. Don't get confused here. Look at it. Okay. Wait, is this the one I want to do? Hold on. Let's just see how it goes, folks. Let's just see how this goes. Everyone, notice how I like hesitated and I put that little X on the bottom at the end? Go back and watch it in slow-mo. You'll see that I sort of snuck it in there in the last second. This little X here. Okay? Let's see how galaxy brain am I? Or how empty vacuum of space brain am I? Let's see how it turns out. Let's go. Let's try this integral. Let's try it. Try. Okay, you look at it. You know, it's not quite in the ordinary substitution regime. If that little x on the bottom were on the top, ordinary substitution would get you home. But it sucks, it's on the bottom. You can try integration by parts, by separating it out. Maybe it'll get you somewhere, maybe it won't, whatever. It sucks. It looks bad to me. Okay, it looks bad. Okay, so what I'm gonna try here is something called, smooth brain. Yeah, smooth brain. Right, am I smooth brain or galaxy brain? We're gonna see. Okay, but what we're gonna use here is something known as a trig substitution. Okay? That's the concept we're going to use for this problem. Believe it or not. Okay. Now, which trig substitution will we choose? Well, we got to go back to our choices here. Okay. Okay. So what we're facing, let me show you what we're facing. We're facing this. Okay. Now, here's something to pay attention to. Square minus number. Square minus number. That's not quite 1 minus square. It's off by a negative sign, and negative signs are disastrous under square roots. You don't want to do that, folks. So, in this case, believe it or not, in this case, it's better to use this one by putting it off to the other side. Look, if you put this onto the other side, you'll get a square minus a number. And it's trading off with a perfect square. See that? That's the one we're going to use. So, we're going to use tangent squared is secant squared minus 1. This is my guiding light. Okay. We're going to do that, and what that suggests, what the light is telling me, my galaxy brain, is inflate x to look like secant theta. Just make it happen. Make it happen, folks. Okay. Stick it in there. All right. Now, dx is then secant theta tan theta by the quotient rule. Secant theta is 1 over cosine. So go do quotient rule, and you'll find this every single time you do it. You'll find the same answer. You'll get secant times tan. Brilliant. Okay, now substitute. Execute. Go. Thetas. Go into the world of thetas. So we got the 1, we've got the division sign, we've got the integral sign. Same. Now x. X is this garbage. And just go and plug it in. And remember this formula. 1 over x, this little x, which I snuck in last second. That's secant theta. And I suppose we're doing, okay? My coloring scheme is all gone now, but whatever. Okay, that's x, square root of secant squared minus 1. But hold on. Secant squared minus 1 can be traded for this perfect square, which is the best because we're underneath the oppressive regime of a square root. Dx. The element dx gets swapped out by this expression. And now you squint and you do a little math. Wow. Incredible. This is just wow. Wow. Now, chat and Discord and everybody, what do we do next? What do we do next? What's that word? That magic word. Respect. 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 Absolutely. Respect it. All right, so how do you respect it? You go here and you undo this. You unpackage that transformation. Means that theta is the arcsecant, the inverse function of secant. And then you're done. So, summary. The integral of 1 over x times the square root of x squared minus 1 is arcsecant of x. The inverse function of secant. Incredible. Absolutely stunning that we could actually get through these kinds of integrals. All right. Next, I start playing some silly games. So now I'm going to start trolling you. Now, I become a troll. So those were the first basic examples where a trig substitution just melts the integral away. And the underlying idea is, I've already explained it. Okay, so now I become a troll. And we're gonna learn how to tackle even... We're gonna learn how to deal with trolls here, because that's what Twitch is all about. All right, here's a troll problem. Okay, so you go and you start looking. You look at your identities. Oh God, cosine squared is 1 minus sine squared. Oh no, 1 plus tangent squared is secant squared. Oh no! Oh no, this is a 1, not a 4. So on the nose, my principle of taking a square plus a number and packaging just as a simpler, just a square-like object, we're not in that regime. We're not quite lined up that way. Okay? However, what I do want to show you is the following trick. So how to get there. How to get back in the trig substitution mode. Yes, true. True that the 1 is not a 4. But you can make it a 4 by multiplying everything by 4. You see that? You can do that. That's also a truer. Oh wait, what? Ah, go pokes. Go pokes? That suggestion where you break the 4 into 1 plus 3, that suggestion is wonderful. You should go and see if it gets you, if applying that trick and then substituting x equals tangent, you should see if that actually simplified your integral or not. You'll find that it doesn't. And what you actually want to do is think more in terms of factoring rather than crumbling off a 1 out of the number. You want to think more in terms of factoring, if that makes any sense. So look, just follow me for a second, and then after class, I'll try to follow you. And we'll see that one way gets through and one way is a stumbling block. But that mistake is a great mistake to make, because only you will understand the wisdom of multiplying by 4 here rather than adding 3, which is what you're thinking. Okay, so here we go. Here we go. Multiply by 4, and now look at this. Just kind of repackage. This is 2 times tangent, all squared, plus a 4 equals 2 times secant, all squared. Okay, so I'm writing it this way for you to see the utility. The utility is still there. 4 plus a perfect square, you can trade it off for a perfect square. Okay, so, but let's go execute it in this case. So what this suggests, this is my guiding light, my inspiration. This inspires me. It inspires me to try the following. So students learn from this experience. You substitute, I'm going to substitute 2 times tangent. Okay, I'm going to substitute 2 times tangent this time. And then dx becomes 2 times secant squared. Okay, and now I follow my nose. One over x squared plus 4. Now what is x? It's this. I delicately put a 2 there and not a 4. I put the square root of 4. You see where it came from. I put the square root of 4 right in front of tangent. Because then, and then here, dx, be careful, dx is just 2 times secant squared. But check this out, this part, right here, is on the left side. I can trade it off for 4 secant squareds. Be careful here, there was a 4 there, not a 2. Now 2 divided by 4, last I checked, was 1/2. secant squared divided by secant squared was 1. Equals 1/2 times theta. Plus any number you'd like. 5 trillion, whatever. Or 0, or -5. Okay, but now class. Are you awake, class? Hey, 38, maybe half of them are students. Hey, students, you guys awake? Okay. What do we do? What must we do? Yes, respect. Mad respect. Homies. Theta. Get it back into X territory. Go back to where it came from. X equals tan theta. So 2 times tan theta. Alright, now you gotta solve for theta out of this. So you divide out by the 2. Tan theta. And then apply arctan to both sides. Apply the inverse function of tangent. Just like ln cancels e to the x. Similarly, arctan cancels tan. Okay, apply arctan. And you get arctan of x over 2 equals theta. And then stick it in. So, our conclusion was this. Was, careful, 1/2 times theta. We defeated that slightly different problem. Just because there wasn't a 1 there doesn't mean you can't proceed. What you do is you kind of multiply the identity you like with a cleverly chosen number. And then that will guide what your substitution should be. Okay, so this was like my little example of that principle. Okay, so this is 12:15. So I will start next class with, again, slight changes on the perfect, pristine examples. Like this one, where we're just like a simple substitution, x equals sine, or x equals tangent. Crumbled the problem. We're gonna do slight variations on those themes. And then we'll up the heat one last time, and that'll be what we do on Friday, I guess. So we're just gonna keep slightly altering these examples to show you that there's more here than just those first 3 examples. That's my goal. Okay, awesome. So we've got some people redeeming things at the end of class. We've got Jasonin. Here's your shungite for today. Take this, absorb, well, anti-absorb it, because what it does is it absorbs the 5G radiation. So here you go. Put your face close to the screen. Are you in public? Then definitely do this. Put your face all the way up against the screen, especially if you're in public. That way you get more of this anti-5G effect, and it'll help you throughout your day. There you go. There's your shungite. We also had Washcloth wants me to play something. The shungite is very heavy. That piece of shungite is let me check. It is 80 pounds. So I mean, I'm strong, but yeah. So it's 80 pounds. All right. Washcloth, you have a recorder. What do you want me to play? I mean, you're gonna ask for some crazy, impossible song. So whatever. What do you want? Washcloth. You want NBA? But wait, Washcloth is the one who redeemed it. Play something hardcore. Well, students last class really liked. Did I already play this Britney Spears song called Toxic? Maybe I already did for this class. Man, I really have to learn some new songs. No, please? Is that a no? Please play it? All right, Sparky. Absolutely. Just for you. I interpreted your answer as no. Please play it. All right. I gotta just warm up here. Couple scales. Okay, ready? Okay. There you go. You had it. I've played it better in the past. If you look at my previous videos, you'll find me playing it better. I think it's because I'm seated right now. When I'm standing, I have more ability. So, and there might be something about the humidity today. Not sure, but something was a little off today. Anyway. Okay. It's the humidity. That's right. Yeah, Dr. Young's lab also is also kind of a bummer to have around usually. So that also, I'm sure everyone else in chat is feeling some kind of some sort of, I don't know. It feels like a throbbing kind of sadness, like on the left side here. That's not you. That's just because Dr. Young's lab is nearby. So that happens. I mean, that's his effect on people. All right. Shungite. You want more Shungite? Tropical Geek? Here you go. May the 5G radiation not affect you today. There you go. 3 circles. There you go. I'm glad people are using their channel points. They're investing in good, high quality content. Awesome. All right, some thank yous. Phil, thank you for following, and I guess that's it. So yeah. All right. Yeah, the room, Bungin. Yeah, the room is not ideal. It's not the usual venue. Like I usually play in, symphonies and all that. And there the walls have these panels on them. And so you might not be hearing the true my true sound, the symphonic sort of sound I have. So that's another issue. Okay. Now, class, I had to teach 2 classes and just so taxing on this third eye. So I really have to start heading out. Let me play some garbage background music. And now, where should we go, class, today? Yes, it's the BMP SO. That's right. The Boring math professor. Symphony orchestra. Right. That's it's under development. And the servant is creating it as we speak, right? Okay. Newt Catone. Newt Catone. Thanks for following. Okay. So it is, yeah, me leaving is definitely for the best. Me getting out of here is definitely for the best. Class was dismissed a long time ago, way before the Britney Spears song even. So please go home. And now we're gonna raid someone. Who are we gonna raid though? Willie's Saloon. Oh yeah, class, go take the exam. Yeah, class, you gotta go take the exam at 1. Go do that. And don't take it at Willie's Saloon. Take it somewhere else. Don't go to a saloon. Easy. All right. Melko. Melko's online? All right. Melko. Let's see. Melko is online? Off Melko. Yeah, Melko's online. All right. Hey, folks. Professor Melko is like the sort of one of the greatest educational streamers in his town, the small town. So go check Professor Melko out. They're one of the top streamers in their family. So we're gonna go check Melko out and give Melko all the love and support. Yeah. Let's see. Of course, Roosta. Yeah. Thanks for showing up to class. All right. Oh yeah, Melko's gonna be a father. That's really cool. All right. So let's go spread the memes. And let's try to derail his class. No, don't do that. Don't do that. Respect. That was today's word. Right, class? Today's word was respect. That's what we learned today. Okay. So let's get out of here. I'm starting the raid, so goodbye. Raid, and I don't know when exactly the raid starts, but it starts at some point like right now. Are you guys gone? Raided? Raid complete.